Okay, I'm going to do this example problem, and I'm going to use a technique different from a previous video where I solved the same problem. And we're given two IP addresses, each with a subnet mask, or we're given our own IP address and our own subnet mask, and the question is this destination IP address within our subnet? And what we're going to do is we're going to use the rule that says that two IP addresses are in the same subnet if their addresses agree in every bit where the subnet mask is 1. In other words, the subnet mask answers the question for each of the 32 bits in the IP address, do the IP addresses need to match? And we can see that the subnet mask has 3 255s in a row for the first 3 octets. A 255 is 8 ones in binary. And so what this is saying is that the first octet needs to match, all 8 bits need to match. The second octet needs to match, all 8 bits. The third needs to match, all 8 bits. And then the action is going to be in the 4th byte, and we're going to go take a look at that. And we can see by inspection that the first bytes match the seconds, 192s, 168s, and 10s. So everything's okay in the first 3 bytes. All we have to do is ask ourselves which bits of the 192 are 1, and in binary notation, do the 115 and the 215 match on those same bits? Okay? So what I'm going to do is I'm going to note that mask of 255.255.255.192. Oh, what's going on here? So we have 8 ones, and that implies the first byte, or the first octet of the IPs must match to be in the same subnet. Okay, and the second byte must match. The third byte must match. And we do have a match. On the bytes, or octets, 1, 2, and 3. The 192.168.10.x for both of those IP addresses, okay? We got a match on the first 3 bytes. Okay, let's look at the 192. 192 is one of those special numbers that we remember the binary representation of pretty easily, because 192 is 128 plus 64. Which means that in binary it's 11000000. This is the 128's place. This is the 64's place. And we can just double check 1, 2, 4, 8, 16, 32, 64, 128. Good. And so now what we're going to do is we're going to say that, okay, the binary representation of the 115 and the 215, we're going to check to see whether their binary numbers match in the first 2 bit places, okay? And so what I'm going to do is I'm going to write the 115 and the 215 as binary. If I write the right number here. 115 is less than 128, so it's a 64, and then plus 32, which is 96. And so we got 19 more to go, which is going to be a 16 plus a 3, plus 2 plus 1. And that means that 115 in binary is 0 in the 128's place, 1 in the 64's, 1 in the 32's, 1 in the 16's, 0 in the 8's, 0 in the 4's, 1 in the 2, 1 in the 1. Okay? The 215 is greater than 128, so it's going to be 128 plus 64. 128, that's 192 so far. 8 more to 200, 8 and 15 is 23. 23 is 16 plus 7, and 7 is 4 plus 2 plus 1. So this is a 1 in the 128, 1 in the 64, 0 in the 32, 1 in the 16, 0 in the 8, 4, 2, 1. Okay, so what we're going to do now is we're going to line these up. Here's the mask. Here's the 115. Here's the 215. 1, 1, 0, 0, 0, 0, 0, 0. The 115 is 0, 1, 1, 1, 0, 0, 1, 1, and the 215 is 1, 1, 0, 1, 0, 1, 1, 1. And now what we're going to do is we're going to say, okay, we need agreement here, because those are where the mask bits are 1, and the question is, do they agree here? And the answer is no. Hence, they're not on the same subnets. Okay? And ultimately, it comes down to the fact that when we have a 192 here breaking up a Class C subnetting is the first type of subnetting you're going to learn because it's all in that last octet. When you have a 192 there, it is a 1-1. It takes 2 bits for the S bits. And what that means is that 2 squared or 4, we're dividing the last octet into 4 pieces. And those chunks are each of size 64. And they are in the ranges of 0 to 63, 64 to 127, 128, where I'm just counting by 64s, 192 to 255. And we can see here that 115 is in this range here, and that 215 is in this range here. Okay? And so they're not in the same subnet. The other thing you can notice is that if we number these subnets 1 to 4 in binary, 0, 0, 0, 1, 1, 0, and 1, 1, that the bits in those first 2 positions, which are labeling the subnet, the 115 is in the 0, 1, and the 215 is in the 1, 1. And so you can see here that these bits, these first 2 bits in the IP address are labeling the subnet. And that's why the mask asks, are those bits the same? If they are, they're in the same subnet because they're in the same labeled subnet. Okay, so there's another way of kind of looking at this problem. And that relates back to the first video on this problem. Okay, I hope that helps.